Hello viewers, today we have a simple task which is to calculate the average velocity, the average acceleration, and also calculating the instantaneous velocity and also the instantaneous acceleration. So we have our question number 1, which is saying the position of a particle is given by x as a function of t, which is equal to 3.0 t squared plus 0.5t to the power 4 meters there. So we have the position, which is the displacement function that has been given to us. So we have part 1, which is saying calculate the average velocity between 1 second and 3 seconds. That's our part 1. So we have our function, which is x as a function of t. This is equal to 3.0 t to the power 4 plus 0.5 t to the power 4 meters. So this is our displacement function that has been given. So part 1 is asking us to find the average velocity, that is between t equal to 1 second and t equal to 3 seconds. So we say the average velocity is equal to the change in displacement over the change in time, where the change in displacement is equal to the final position minus the initial position over the final time minus the initial time. That's the formula that we use here. So now we need to find the final position. So the final position, this is the distance. This is the distance when t is equal to 3 seconds. So we'll get our function, which is x as a function of t, which is equal to 3t to the power 2 plus 0.5 to the power 0.5t to the power 4 meters. So at the t, we're going to substitute with a 3 so that we find the final position. So I'm going to say the final position here will be equal to 3, while the t will substitute with a 3. Then this is squared plus 0.5. Then open brackets, while the t we are putting a 3. Then to the power 4 meters there. So the final position will be equal to the final position will be 67.5 meters. Then given the final position, we can also find the initial position, which is when t is equal to 1 second. So when t is equal to 1 second, we'll substitute again. So the initial position will be, while there's t, we'll put a 1. So 3 open, 1 squared plus 0.5. Open brackets, you have a 1 close to the power 4, that is meters there. So the initial position will be 3 plus, that is 3 times 1 squared plus 0.5 times 1 there. So you should be able to get a 3.5, that is meters. So now we come and substitute here. We say the average velocity will be equal to the final position. We have that is 67.5 meters minus the initial position, that is when t is equal to 1 second. We have 3.5 meters, that is over the final time is 3 seconds minus the initial time, which is a second there. So the average velocity will be equal to, so on top we have 67.5 minus 3.5, so that will give us 64, that is meters, over 3 seconds minus a second. This will give us 2 seconds. So now when we divide 64 divide by 2 to give us, that is 32 meters per second. So that one becomes our average velocity. So that one becomes our average velocity. So now moving to part 2, which is saying we have to calculate the average acceleration between t equal to 2 seconds and 3 seconds. So we have our part 2, which is requesting us to calculate the average acceleration between t equal to a second and also between t equal to, and also 3 seconds there. So to calculate the average acceleration, we say the average acceleration is equal to the change in velocity over the change in time, where the change in velocity, it is actually the final velocity minus the initial velocity over the change in time, that's the final time minus the initial time. So here we have our position function. So our position function is equal to 3t squared plus 0.5 t to the power 4 meters. So we can obtain our velocity function by differentiating this our position function. So we're going to say the velocity function as a function of t. This will be equal to, so we differentiate this our function. So drop a 2 times 3, that will give us 6t. Then 2 minus 1, the power will be 1 there. Then plus 4 times 0.5, that will give us a 2. That is t. 4 minus 1, it will give us a 3 there. Then we have meters per second. So that one becomes our velocity function. So now, given our velocity function, now we can calculate the final velocity. So the final velocity, this will be the velocity when t is equal to 3 seconds. So we'll get our velocity function. Now what is t, will substitute with a 3. So I have 6 open, then here we have a 3 plus 2 open, then we have a 3, that is to the power 3. This will give us, so this will give us a 72, that is meters per second. So that one becomes our final velocity. Then the initial velocity, this is the velocity when t is equal to 1 second. So we substitute again what is t, we're going to substitute with a 1 so that we find the initial velocity. So we have 6 open brackets, we have a 1 plus 2 open brackets, you have a 1 to the power 3. So the velocity would be 8, that is meters per second. So that one becomes our velocity. So now the change in the acceleration is equal to the final velocity. We have 72 meters per second minus the initial velocity. We have 8 meters per second. Then we divide this by the final time, which is 3 seconds, minus the initial time, which is a second. So when we punch on top, we have 72, that is minus 8. So this will give us 64 meters per second over 3 minus 1, it will be 2 seconds here. So when we divide, we have 32 meters per second squared. So that one becomes the average acceleration of our question. So now moving to part 3. So we have our part 3 now. So when you look at part 3 is saying that calculate the instantaneous velocity at t equal to 2 seconds. Calculate the instantaneous velocity at t equal to 2 seconds. So at t, that is part 3, so I have to find the instantaneous velocity at t equal to 2 seconds there. So for us to calculate the instantaneous velocity, we need to obtain our velocity function. Since we have our position function, which is equal to 3t squared plus 0.5, that is t to the power 4. Then this is meters. So we can obtain our velocity function, because remember the instantaneous velocity, for you to get the instantaneous velocity, you differentiate the position function. So if you remember, we had differentiated this, and we'll differentiate again anyways. So you drop a 2 times 3, we have a 6t. Then this will be drop a 4 times 0.5, we have a 2 there. Okay, so we have that is 2t, then 4 minus 1, we have a 3, then the units meters per second. So the instantaneous velocity when t is equal to 2 seconds, meaning that what is t, we are going to substitute with what, a 2. So the velocity when t is equal to 2, So I have 6 open brackets, here we substitute with a 2, plus 2 open, here we substitute with a 2 to the power 3, then the units we have meters per second. So the instantaneous velocity when t is equal to 2 seconds, you're just punching that on your calculator. So I'm getting the instantaneous velocity to be 28, that is meters per second. So that one becomes the instantaneous velocity. Then now the last part is asking us to calculate the instantaneous velocity, that is at t equal to 2 seconds. So to calculate the instantaneous acceleration, it's asking us to calculate the instantaneous acceleration. So for us to calculate the instantaneous acceleration, we need to differentiate our velocity function that we have obtained. So if you see, our velocity function is 6t, that is plus 2t to the power 3, that is meters per second. So for us to get the acceleration, we're going to differentiate this our function. So say the acceleration is equal to, here when you differentiate 6t over 6, plus you drop a 3 times 2, that's a 6, then t to the power 2. Then the units becomes meters per second squared. So we are going to substitute, where there is t, we are going to put a 2. So to be 6 open brackets, here we have a 2. So the acceleration, which is the instantaneous acceleration, becomes so the instantaneous acceleration is now 30 meters per second squared. So that one becomes the instantaneous acceleration for our question there.